So today we're going to continue with this coordinate geometry idea. We're going to deal with quadrilaterals specifically today, and first off, this is labeled example 2, it should be called example 3. And they want us to identify what type of quadrilateral this is. So the types of quadrilaterals we have are a parallelogram, what we're looking for is both pairs of opposite sides parallel. If I'm trying to identify a type of quadrilateral in coordinate geometry, that's the first place I go to is it a parallelogram or not? Okay, if it doesn't look like a parallelogram, I mean, these are being graphed, right? So if lines look like they're going towards each other, they don't look parallel. These are somewhat drawn to scale, so you can make those assumptions. If it looks like a parallelogram, that's the first place I go. Looks like a parallelogram, let's try that. If it's a rectangle is a parallelogram with 4 right angles. Okay. We're already going to be finding slopes to establish parallel lines for the parallelogram. So once we get all the slopes of all 4 sides figured out, if we see that the consecutive sides are opposite reciprocals of one another, those create right angles. All right, if it's a square, that's going to be a rectangle with all sides equal. If it's a rhombus, it's a parallelogram with all sides equal. So once you go to the trouble of finding out it's a parallelogram, then look to see what the lengths of the sides are to see if they're the same length, in which case it's either a rhombus or a square. If you've got the right angles, square. If you don't have the right angles, rhombus. The other 2 types, or we'll deal with in those examples 4a and 4b, that involves a trapezoid or a kite. So if it looks like a parallelogram, start with the parallelogram idea. This one looks like a parallelogram. It looks like it might be a rectangle, but I can't quite tell those are right angles or not, so I'll have to do some slopes. But all I want to do to determine parallelogram is just find the slope of each side. So the slope of ST is equal to something. The slope of TU is equal to something. The slope of RU is equal to something. And the slope of RS equals something. And the slope formula is what it always has been. It's y minus y over x minus x. The coordinates, I can maybe establish those. So r is 1 right, 1, 2, 3, 4, 5 up. S is 2 right, 1, 2, 3, 4, 5, 6, 7, 8 up. T is 1, 2, 3, 4, 5, 6, 7, 8 right, 1, 2, 3, 4 up. U is 7 right, 1 up. Right, so we establish those points. So then it doesn't really matter what point 2 and point 1 is. I'm just going to go with the names here. S point 1, T point 2, T point 1, U point 2, R point 1, U point 2, like that. So when I'm doing Y2 minus Y1, I'm doing point T minus point S, point U minus point T, and so on. So Y is on top. T minus S is going to be 4 minus 8 on top. Y minus Y over 8 minus 2 on the bottom, 8 minus 2. The order of subtraction must match. So this is first, this is second. This is first, this is second. That's the requirement when you're subtracting these things. The order on top doesn't matter as long as it matches the bottom. We're always subtracting unless we get minus negative. 4 minus 8 is negative 4. 8 minus 2 is positive 6. That's negative 2/3 reduced lowest terms. So always reduced lowest terms, easier to compare things. If I'm doing TU, 0.1 T, 0.2 U, so this minus this, U minus T is what's happening. So Y minus Y is going to be 1 minus 4, X minus X is 7 minus 8. 1 minus 4 is negative 3, 7 minus 8 is negative 1. That's going to be positive 3 over 1. Okay. right off the bat, the consecutive sides here, notice -2/3 is not the opposite reciprocal of +3/1. So this is not a right angle, so I already know immediately it's not a rectangle or a square, so that these two are out. And I'm still determining if it's a parallelogram or not, but again, as I'm finding these slopes, I can very easily identify whether right angles exist. Continuing on, if I'm looking at RU, R.1, U.2, so 0.2 minus 0.1, so y minus y is 1 minus 5, and x minus x, 7 minus 1. That makes 1 minus 5 is -4, 7 minus 1 is +6, -4, 6 is -2/3. That's exactly the same as -2/3, so these two lines here are parallel to one another, so I know for a fact that ST is parallel to RU. My final slope I'm concerned with is RS, R.1, S.2, y minus y, x minus x, s minus r order, so 8 minus 5 on top, y minus y, over 2 minus 1 on the bottom. 8 minus 5 is 3, 2 minus 1 is 1, 3/1 is 3/1. So 3/1 matches 3/1. These are parallel to one another as well. So we know that much is true. Okay, finally, if I want to determine if it's a rhombus or not, it's definitely a parallelogram. We need to look at the side lengths. So if I want to find the lengths of the sides, this, and this would have to be the same measure. We already know for a fact it's a parallelogram. Parallelograms automatically have opposite sides equal. So these two sides will be equal, those two sides will be equal for sure. So I'm just going to find the length of RS and find the length of ST to see if they match. If they do, fine. If not, it's just a parallelogram. They don't look like they are the same, right? It's sort of drawn to scale, so I'm already banking on the fact probably not the same, but it's good to practice this stuff. So if I'm looking at RS, that equals the square root of parentheses squared plus parentheses squared. If you recall from yesterday, we fill in the parentheses with how far apart are the values. So how far is it from 1 to 2?
1.
How far is it from 5 to 8? 3. Okay, that's all that is. That's all distance formula ever will be. How far apart are the x's of the 2 points you concern yourself with? How far apart are the y's of the 2 points you concern yourself with? 1 squared is 1, 3 squared is 9, 1 plus 9 is 10. So RS is the square root of 10, which means this is also the square root of 10, because again, it's a parallelogram, opposite sides have to be equal. I want to find the length of ST, same deal, square root of something squared plus something squared. S to T, 2 to 8 is 6, and 8 to 4 is 4. 6 squared is 36, 4 squared is 16, add them up, you get the square root of 52. These side lengths are not the same. Opposite sides are equal, but all 4 sides aren't the same. So it's not a rhombus, so this is simply a parallelogram. So again, parallelogram is the most basic parallelogram. Rectangle has all right angles. A square has right angles and equal sides. A rhombus has no right angles but equal sides. Actually, a rhombus would have, a rhombus could have right angles, but a rhombus, just generic one, doesn't have to have right angles. So all sides equal. If right angles and sides equal, then you've got a square. So that'd be how to establish what quadrilateral it is. All right, that's how you do that.